Dengan tuntutan era digital yang semakin pesat, memacu kita untuk terus meningkatkan potensi sumber daya manusia yang terintegrasi dan mampu menunjang produktivitas. Namun, perkembangan yang kian padat tersebut perlu diimbangi dengan solusi pembelajaran yang efektif dan modern yang mampu mengimbangi rutinitas masyarakat masa kini. Sebuah sarana yang mampu mengatasi keterbatasan tempat dan waktu yang menjadi masalah utama bagi banyak orang dalam mengembangkan diri dan peningkatan karir di era digital yang berdampak pada gaya hidup. Universitas Terbuka hadir untuk menjawab masalah tersebut dengan penerapan sistem pembelajaran terbuka dan jarak jauh. Sistem yang terbukti efektif meningkatkan daya jangkau dan pemerataan pendidikan tinggi yang berkualitas bagi seluruh lapisan masyarakat. Sistem pembelajaran Universitas Terbuka memungkinkan para mahasiswa untuk belajar secara fleksibel dan terbuka dengan beberapa keuntungan seperti waktu pendaftaran yang terbuka sepanjang tahun, sehingga Anda tidak perlu khawatir untuk terlambat melakukan pendaftaran. Ruang, waktu, dan tempat yang fleksibel bagi mahasiswa. Hal ini sangat berguna bagi para mahasiswa yang tetap ingin mengembangkan wawasannya dimanapun dan kapanpun. Materi ajar cetak maupun digital yang mudah diakses di seluruh pelosok Indonesia dan mancanegara. Memberi kesempatan kepada segala golongan dan usia yang siap belajar untuk mengembangkan ilmu dan kemampuannya di segala bidang. Memiliki 39 kantor regional di seluruh Indonesia dan pusat layanan luar negeri yang selalu siap mendukung kegiatan operasional dan jalinan kerjasama dengan berbagai institusi baik nasional dan internasional. Serta dilengkapi dengan berbagai fasilitas penunjang proses pembelajaran seperti UT Radio, UT TV, layanan bantuan belajar, hingga perpustakaan yang dapat diakses secara online. Memiliki 4 fakultas, Fakultas Keguruan dan Ilmu Pendidikan, Fakultas Hukum Ilmu Sosial dan Ilmu Politik, Fakultas Ekonomi, Fakultas Sains dan Teknologi, dengan lebih dari 35 program studi sarjana dan program pasca sarjana. Universitas Terbuka, making higher education open to all.
Selamat datang di Universitas Terbuka. Kali ini aku akan mengajak kamu untuk virtual campus tour di Universitas Terbuka. Universitas Terbuka atau UT memiliki kantor pusat di Pondok Cabe, Tangerang Selatan, serta 39 unit program belajar jarak jauh atau UPBJJ yang tersebar di seluruh Indonesia. Dalam rangka mendukung layanan kepada mahasiswa, berbagai sarana dan prasarana dibangun dan terus ditingkatkan kualitasnya. Ayo kita mulai. Di kantor pusat, terdapat gedung fakultas yang merupakan jantung dari pengembangan produk akademik UT. Gedung fakultas telah dilengkapi dengan sarana dan prasarana untuk mendukung kenyamanan bekerja. Terdapat 4 fakultas di Universitas Terbuka dan 1 sekolah pasca sarjana. Fakultas Keguruan dan Ilmu Pendidikan, Fakultas Sains dan Teknologi, Fakultas Hukum Ilmu Sosial dan Ilmu Politik, dan Fakultas Ekonomi, serta Sekolah Pasca Sarjana. Gedung fakultas memiliki sarana dan prasarana yang terstandar yang terdiri dari masing-masing fakultas menempati 2 lantai. 1 lantai diperuntukkan untuk ruang layanan mahasiswa, ruang konsultasi mahasiswa, ruang dekan, ruang wakil dekan, ruang kepala bagian tata usaha, ruang tenaga kependidikan, dan ruang sidang. Ruang sidang dilengkapi dengan fasilitas video conference yang digunakan untuk rapat koordinasi dengan dosen yang tersebar di UPBJJ, serta ujian sidang untuk mahasiswa pasca sarjana. Ruang dosen menempati satu lantai yang terdiri dari ruang sidang, ruang dosen, ruang ketua jurusan, dan ruang ketua program studi. Masing-masing lantai dilengkapi dengan ruang makan, musola, dan toilet yang nyaman dan bersih. Masing-masing dosen dan tenaga kependidikan memiliki kubikel sebagai ruang kerja. Kubikel ini berukuran 2 kali 1,5 meter. Setiap kubikel dilengkapi dengan komputer yang telah terinstall Microsoft 365 yang berlisensi. Untuk mendukung layanan kepada mahasiswa, Universitas Terbuka juga memiliki beberapa sarana dan prasarana pendukung sebagai berikut. Pusat Produksi Multimedia merupakan unit pelaksana teknis yang bertugas untuk memproduksi bahan ajar. Gedung ini dilengkapi dengan peralatan produksi materi-materi dalam bentuk video dan audio. Produksi materi cetak juga diproduksi di sini dengan menggunakan peralatan dan software terkini. Pusat Layanan Bahan Ajar merupakan unit pelaksana teknis yang bertugas untuk melakukan distribusi bahan ajar. Gedung ini dilengkapi sarana dan prasarana untuk menyimpan dan pengemasan bahan ajar dan bahan ujian. Pusat Layanan Pustaka atau Puslata. UPT Puslata melayani penyediaan bahan-bahan pustaka bagi mahasiswa dan dosen. Puslata mengelola penyediaan bahan-bahan pustaka baik dalam bentuk hard copy maupun koleksi digital. Koleksi digital yang dikelola melalui Perpustakaan Digital UT. Perpustakaan Digital UT menyediakan layanan akses bahan ajar melalui ruang baca virtual. Di sini juga dapat diakses berbagai sumber pembelajaran terbuka melalui Suaka UT dan sumber pustaka online lainnya seperti jurnal dan e-book. Pusat Pengujian merupakan UPT yang memiliki tugas untuk melakukan pengelolaan bahan ujian dan hasil ujian. Gedung Pusat Pengujian dilengkapi dengan sarana dan prasarana untuk melakukan pengelolaan bahan ujian. Bank Soal UT mengelola koleksi soal-soal yang digunakan untuk ujian akhir semester. Penyiapan master naskah ujian dilakukan di Bank Soal. Selanjutnya, penggandaan naskah ujian dilakukan di pusat percetakan dan kemudian didistribusikan ke seluruh Indonesia. Pusat Pengujian juga mengordinasi pelaksanaan ujian online serta pemeriksaan hasil ujian secara online. Universitas Terbuka Convention Center merupakan fasilitas yang digunakan untuk menampung pertemuan dalam jumlah besar dan pelaksanaan wisuda mahasiswa. UTCC dilengkapi fasilitas video conference yang digunakan untuk rapat koordinasi dengan UPBJJ di seluruh Indonesia. Di samping UTCC, UT juga memiliki fasilitas wisma yang digunakan sebagai akomodasi untuk kegiatan yang mengundang pihak-pihak dari luar UT, misalnya dalam rangka pengembangan bahan ajar, pengembangan bahan tutorial, dan pengembangan bahan ujian. UPBJJ sebagai ujung tombak layanan kepada mahasiswa dilengkapi dengan berbagai fasilitas berikut. 1. Ruang pelayanan mahasiswa. 2. Ruang sumber belajar yang dimanfaatkan oleh mahasiswa untuk mengakses berbagai sumber pembelajaran online. 3. Ruang kepala UPBJJ. 4. Ruang kerja dosen dan ruang kerja tenaga kependidikan. 5. Ruang sidang yang dilengkapi dengan fasilitas video conference yang digunakan untuk rapat koordinasi dan pelaksanaan ujian sidang. 6. Ruang tutorial yang disediakan untuk memfasilitasi tutorial tatap muka yang dilaksanakan di UPBJJ. Dan 7. Ruang ujian online. Gimana? Seru kan virtual kampus tour-nya? Terima kasih sudah mengunjungi Universitas Terbuka. Sampai jumpa. Universitas Terbuka, making higher education open to all.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. First, I would like to welcome Professor Takuya Sugahara, Ph.D. from Ehime University, Japan. And I would like to welcome Dr. Mohamad Yunus, SSMA, as the Vice Rector of Academic Affairs of Universitas Terbuka. And also, Dr. Subekti Nurmawati, M.Sc, as the Dean of Fakultas Sains and Teknologi. Dr. Indah Novianti, M.Sc, as the Head of Agriculture Department. Dr. Andes Eka Yulias Tuti, M.Sc, as the Head of Food Technology Study Program. In Rajih Radiansyah, B.AS M.Sc, as a Moderator. And last but not least, to all participants who have attended this event. Welcome to guest lecture, The Functional Food Development of Local Citrus Orange in Ehime, Japan. Held by Food Technology Study Program, Fakultas Sains and Teknologi, Universitas Terbuka. I'm Didi Nurhatiki. I feel very honored to be master ceremony for today's event. Ladies and gentlemen, first of all, let us be thankful that we can gather here today, Wednesday, November 10, 2021, because over the next few hours, we will have opportunities to discuss and share knowledge, insight, and best practice about how to develop functional food from local commodity in Ehime, Japan. Excellencies, ladies and gentlemen, I would like to explain the schedule for today's event. First, opening ceremony start by National Anthem of Indonesia and followed by opening prayer. And we will continue with the welcome speech by Vice Rector of Academic Affairs of Universitas Terbuka and welcome speech by Dean Faculty of Science and Technology of Universitas Terbuka. Then we will continue with the main lecture from Professor Takuya Sugahara, Ph.D., then followed by question and answer discussion. And it will end with the closing ceremony. Ladies and gentlemen, as a start of our opening ceremony, we will sing the national anthem of Republic Indonesia. We would like to request you to remain seated during the song. Thank you. Before we start our guest lecture, let's pray together according to our respective religion and beliefs. Please start praying. Okay, prayer time is over. Next agenda is a welcome speech by Vice Rector of Academic Affairs of Universitas Terbuka, Dr. Mohamad Yunus, SSMA. Please welcome Dr. Yunus. Stand is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, selamat pagi, and best wishes to all of us. To the Honorable Professor Takuya Sugahara, of Ehime University, Japan, as today's guest lecturer. Dr. Subekti Nurmawati, Dean of Faculty of Science and Technology, Universitas Terbuka. Engineer Muhammad Rajih Radiansyah from the Food Technology Study Program, Faculty of Science and Technology, as a moderator. To whom we respect, Head of Agriculture Department, Science and Technology Faculty, Dr. Insinyurinda Novianti, Head of Food Technology Study Program, Dr. Eko Yuryastuti, Master of Science, and to all lecturers of Universitas Terbuka from Food Technology Program and of the faculty, as well as the participant of today's lecture. I want to say thanks that you are able to join this guest lecture for the next 2 hours. First, let us say thanks to God for, due to their blessing, all of us here and able to meet and learn in this guest lecture with the theme of the functional food development of local citrus orange in Ehime, Japan. To our lecturers participants, soon we are going to listen together learning materials about functional food, especially functional food based on locally sourced ingredients from Japan that will be presented by Professor Takuya Sugahara. We would like to say welcome and thanks to Professor Takuya Sugahara for sharing his time and knowledge in today's forum about functional food as a hot topic to be discussed. This is true especially in this COVID-19 era, where people consume food not only for safety but also for health. The discussion of functional food is even more exciting when it includes an expert in the field. 3 months ago, Food Technology Study Program had the opportunity to discuss locally sourced functional foods with a few professionals from Indonesia. The potential of Indonesia's local commodities to be developed as bioactive functional food is quite high. Therefore, today we have the opportunity to learn more about how such foods are developed in other countries, such as in Japan. As commonly known, Japan is a technologically advanced country, including the food technology field. Japan has a history of using food for health benefits, including development of functional foods. Innovation and research in functional foods are the bridge for developing better and fast and tastier functional food. We hope with this lecture that we as academic and as a society are more driven to innovate and create locally based food products that are both enjoyable and healthy. Indonesia, with its limited potential of rich and diverse food commodities, are waiting to be discovered. Our cooperation is not limited to this lecture. Further talks about development of learning materials, research, and community service, of course, is possible. This is in line with the mission of our Food Technology Study Program, which is to be the trigger and the driver for the innovation of locally sourced food commodity. So, through this lecture, we hope that the information and knowledge given by Prof. Sugahara are beneficial and bring new ideas, insight, and innovation to all of you. We would like to give thanks to the Food Technology Study Program team, the University's ICT team, the Faculty of Science and Technology, and as well as the other parties that help with the arrangement of today's lecture. To all our participants, have a good and educational journey and experience. God bless us to all. Amin. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Dr. Yunus, for the warm welcome. And then we would like to wish you a happy birthday because today is Dr. Yunus' birthday. Happy birthday, Dr. Yunus. We wish you a good health and success. Next, let us continue to hear the welcome speech for the Faculty Science and Technology, Dr. Subekti Nurmawati, M.Sc. Please welcome Dr. Nurma.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning and best wishes to all of us. Honorable Professor Takuya Sugahara from Ehime University, Japan. Dr. Yunus SSMA, Vice Rector for Academic Affairs Universitas Terbuka. All of Vice Deans, Head of Agriculture Department, Mrs. Dr. Insinyur Rinda Novianti M.Sc, Head of Food Technology Study Program, Mrs. Dr. Randa Eko Yuliastuti M.Sc, and all lecturers of the Food Technology Study Program and lecturers at the Faculty of Science and Technology. Ing Muhammad Rajih Radiansyah M.Sc from the Food Technology Study Program as Moderator, and a very good morning to all participants. Ladies and gentlemen, firstly, praise is to Allah Subhanahu wa Ta'ala because with His permission, today we are all able to attend the guest lectures from our extraordinary speaker, Professor Takuya Sugahara, with the topic The Functional Food Development of Local Citrus Orchards in Ehime. This event is organized by the Food Technology Study Program, Fakulty of Science and Technology, Universitas Terbuka, Indonesia. Dear guest lecture participants, today's food is no longer just to meet the body's basic needs, namely nutritious and delicious, but can also be functional, or also known as the concept of let your food be your medicine and let your medicine be your food. During the current pandemic, the consumption of functional food is one of our efforts to increase the body's immunity. Indonesia itself is rich in local commodities. This commodity is grown and cultivated by the local community in following local wisdoms and culture. Local commodities contain bioactive components that have the potential to be developed as functional food. Several studies have found bioactive content in these commodities, but they are still on a laboratory scale. The process of developing functional food is not easy. It requires a long research stage up to the commercialization stage. Ladies and gentlemen, at this guest lecture, we can hear about the best practice in developing functional food in Japan. Professor Takuya Sugahara, on this occasion, will explain the development of one of the famous commodities in Ehime Prefecture, namely oranges. Together with a dairy producer in Ehime Prefecture, a student at the Faculty of Agriculture at Ehime University, he developed a functional drink called N+, a yogurt drink mixed with orange peel. This drink itself has been commercialized since 2015. Hopefully, after listening to this guest lecture, it can inspire us to continue working to develop research that can be useful for the wider community. I would like to thank the Food Technology Study Program for starting this good activity with Ehime University, Japan. Hopefully, in the future, there will be continued collaboration in teaching research and community service. Lastly, the guest lecture would not have been possible without the hard work of various parties. We would like to thank the Food Technology Study Program team and all parties that we have not mentioned one by one, who has helped organize today's guest lecture. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Dr. Ruma, for a very insightful speech. Then, ladies and gentlemen, please kindly take a nice seat as our guest lecture will come on shortly. And please remember to put your microphone in muted mode. Before we start, let's watch informational video of Food Technology Study Program.
Program Studi Teknologi Pangan Universitas Terbuka telah mengabdi selama 15 tahun untuk merealisasikan misi pemerintah dalam hal pemerataan akses perguruan tinggi, khususnya ilmu teknologi pangan, bagi seluruh warga masyarakat dan ikut serta meningkatkan daya tampung perguruan tinggi negeri dengan jangkauan layanan di 515 kabupaten kota di Indonesia dan 50 negara. Universitas Terbuka memiliki 39 kantor unit program belajar jarak jauh atau UPBJJ dan 1 pusat layanan untuk mahasiswa luar negeri. Kurikulum program studi S1 Teknologi Pangan merujuk pada rekomendasi Institute of Food Technologies, KKNI, dan Perhimpunan Ahli Teknologi Pangan Indonesia yang meliputi 6 ranah kompetensi, yaitu 1. Kimia dan analisis pangan, 2. Mikrobiologi dan keamanan pangan, 3. Biokimia, gizi dan kesehatan, 4. Rekayasa proses pangan, 5. Ilmu pangan terapan, dan 6. Kecakapan hidup. Program Studi Teknologi Pangan memiliki berbagai fasilitas untuk menunjang kegiatan akademik dalam rangka mencetak lulusan yang berkarakter dan berdaya saing global. Mahasiswa Universitas Terbuka dibekali dengan buku materi pokok yang ditulis oleh para dosen profesional berkualitas dunia. Proses belajar dilakukan secara mandiri dengan layanan bantuan belajar berupa tutorial online dan tutorial tatap muka.
Oh iya, kalau misalnya masyarakat tangan tapi di baskom sudah tidak, mungkin bisa dicoba dibersihkan dengan sendok tangannya, baru kemudian dilakukan pengadukan lagi. Baik, Bu.
Untuk memudahkan daya jangkau mahasiswa, pelaksanaan praktikum pada program studi teknologi pangan dilakukan kerjasama dengan 16 perguruan tinggi mitra di berbagai daerah.
Halo, nama saya Dita. Saya lulusan pertama dari Universitas Terbuka, jurusan Teknologi Pangan. Saya juga lulusan dari Magister S2 IPB, jurusan Teknologi Pangan juga. Dan saat ini saya sebagai Head R&D di PT The Glow International atau disebut dengan KIBIF. Makasih.
Saya Evi Mardiastuti Silalahi, saya bekerja di salah satu instansi pemerintah Provinsi DKI Jakarta. Saya lulusan Sarjana Teknologi Pangan Universitas Terbuka dan saat ini saya sedang melanjutkan pendidikan saya di Magister Teknologi Pangan Institut Pertanian Bogor. Terima kasih.
Mari bergabung bersama kami di program studi Teknologi Pangan Universitas Terbuka.
Ladies and gentlemen, we have finally arrived at the main agenda. In a few moments, we will listen to today's guest lecture with the theme of the functional food, development of local cytosporine in Ehime, Japan, and the specific topic from research to commercialization and clustering development case. This guest lecture will be moderated by Mohamad Rajih, B.AS, M.Sc. And for information, participants who attend this guest lecture, apart from Indonesia, and also come from very good countries such as India, Malaysia, Korea, and New Zealand. Okay, ladies and gentlemen, I would like to give attention to these following matters. First, please turn off your microphone during this presentation. If you have any question, please write it down to the Q&A section with the format, your name, affiliation, and then your question, or by using the raise hand feature if you would like to ask directly. It is expected that all participants to fill attendance link that will be shared on the chat box at the end of the presentation. Okay, ladies and gentlemen, now I would like to invite Mr. Rajih to get us through an insightful lecture. Before that, I will introduce Mr. Rajih background first. Mr. Rajih is a lecturer in a food technology study program. He graduated from the Hague University of Applied Science in Netherlands for his bachelor in food technology. He then graduated from Ghent University, Belgium, for his master in food technology. His interest include food processing, nutrition, and packaging. Mr. Rajih, if you may get this guest lecture.
Thank you, Ms. Hakiki, for the time. Sorry. Can you hear me? Yeah.
Yes, Mr. Rajih. It's okay.
Assalamualaikum warahmatullahi wabarakatuh. Thank you, Ms. Hakiki, for the time. To the Honorable Professor Takuya Sugahara of Ehime University, Japan, Vice Rector of Academic Affairs of Universitas Terbuka, Dr. Mohamad Yunus, Dean of Science and Technology, Dean of Science and Technology Faculty, Dr. Subekti Nurmawati, Head of Agricultural Department, our faculty, Dr. Rinda Novianti, Head of the Food Technology Study Program, Dr. Andes Eko Yuliastuti, France, and colleagues of the Food Technology and of Universitas Terbuka, and finally, to all the participants of today's lecture. Welcome and thank you from Universitas Terbuka Food Technology Program for your participation. I hope we are always blessed with good health and are able to follow this lecture to the very end. First, let me introduce myself. My name is Mohamad Radiansyah, and I will be the moderator for today's lecture. Ladies and gentlemen, for today's event, we are going to talk about functional food and its development. As mentioned before, Indonesia is a country with a high potential for using functional foods as food products. Last semester, we are fortunate enough to have speakers from various backgrounds to talk about functional foods made out of locally sourced commodities in Indonesia. However, for today, we are going to talk about the kind of functional foods that are made, researched, and developed in another country such as Japan. Today's functional food talk is going to be presented by Professor Takuya Sugahara. Professor Sugahara is a professor at the Faculty of Agriculture at Ehime University in Japan. He graduated from Kyushu University with a doctoral in agriculture. Currently, besides being in Ehime University as a professor, he is also the director of Food and Science Research Center, and in 2016, he was appointed as special aide of the president at Ehime University. He has various research experience in topics of food science, animal cell technology, and functional molecular science. He, during his career, has published over 160 international academic papers, the latest being in 2021 with the title of Aqueous Extract from Leaves of Citrus in Sui Attenuates Lipopolysaccharides Induced Inflammatory Responses in a Mouse Model of Systemic Inflammation. He has also won awards, the most recent being the International Society of Nutraceuticals and Functional Foods 2017 Poster Awards. Without further ado, let us begin with the main event of this lecture. Professor Sugahara, are you ready for the lecture?
Yeah, thanks so much.
Okay, thank you, Professor. You have 45 minutes for the presentation.
Yeah.
Now I will give you the time, Professor, if you may.
Yeah, thank you. Thank you, Mr. Rajih, for nice introduction to me. So first, I'd like to say thank you for this opportunity to present my research experience about the development of functional food using stress peer. So can you share my presentation files? Okay, I'd like to start my presentation about the functional food development of local stress orange in Ehime. So this is the product of the stress peer containing yogurt to prevent the allergy. In Japan, allergy is a very serious problem. So this product contribute to the easing the allergy symptoms. At first, I would like to introduce Matsuyama, Ehime. As you know, here is Japan map, and there are 4 major islands: Hokkaido, Honshu, Shikoku, and Kyushu. So 4 major islands in Japan. And then Ehime prefecture is in this smallest island. Major smallest island. So here is in Ehime prefecture. It is the Shikoku Island. So there are 4 prefectures. So this is the Ehime prefecture, and Matsuyama City is the capital of Ehime. So Ehime is a very famous city because of the very old hot spring. Dogo hot spring. This wooden-made building was established maybe 120 years ago. So the very old wooden-made buildings. So this is the hot spring. This is a very famous architecture in Japan. So here is the Matsuyama Castle. So this castle was built maybe 400 years ago, so the bit old. It's also wooden made. So this top Matsuyama Castle is built on the hilltop. So this is view from the hilltop of the Matsuyama Castle. So not so big city compared with the Jakarta, so but very good scenery and very good weather conditions. So this picture showed the autumn festival in Matsuyama City. It just in front of the Dogo Hot Spring building. So the women this is the Mikoshi. Mikoshi is the kind of god. So the women carry the gods. And this is the autumn festival. Autumn festival is very famous in Matsuyama, Ehime. So here is the Ehime University campus. This is the main gate of the campus. This picture was taken in spring. So this is the full bloom of the cherry blossom. There is very beautiful flower, very beautiful trees of cherry blossom. So Faculty of Agriculture is in the different campus. So this is the Talumi campus. So here is Faculty of Agriculture. This is the main building of the Faculty of Agriculture. So the Ehime is famous in stress. This is the Satsuma is the kind of stress, the very major kinds of stress in Japan, the most major kinds of stress in Japan. So this shows the change in the year of Satsuma. So the red colored line show the totally Japan's year of Satsuma from 1955 until 2012. So maybe 1970s, most of the Satsuma was the product of the Satsuma is much higher. Then, however, gradually decreasing. So now is 1/5 of the peak year. And this green line shows only Ehime Prefecture. So Ehime Prefecture is very famous in Satsuma. So also in Ehime, the year is gradually decreasing. So the year of the top 3 prefectures in Japan. So this is the Satsuma. Wakayama Prefecture is a major prefecture in Satsuma, but Ehime is the number 3 producer. But total citrus. So this is the Ehime means this is the Satsuma. This is the Satsuma. The major species, major kinds of citrus. However, in Ehime Prefecture, there are more than 40 varieties of citruses are produced in Ehime. So the total citrus year is almost same as Wakayama, almost same. So the Ehime is very famous in citruses. So each citrus contains very specific functional component. Citrus Satsuma containing the beta-glucoxanthin. The ponkan, this species of citrus containing the nobiletin kind of flavonoid, the key component at this in this presentation. Kawachi bankan, the yellow colored citrus, it's containing the olaptin. Olaptin is the kind of coumarins. So coumarins have the anti-inflammatory effects and to prevent the immunostimulatory effects. So each citrus contain the specific materials, specific component in fruit, not only in fruit but also pear. So the pear, citrus pear containing the many kinds of functional substances. So I would like to introduce the specific substances containing in citrus. Vitamin C, vitamin A, citric acid, pectin. These 4 substances are contained in not only citrus, but also many vegetables, many fruits. However, beta-glucoxanthin, a kind of carotenoids, the nobility, they kind of flavonoids. and the coumarins, all of them, kind of coumarins. The molecular shape was shown in this slides. The beta-glucoxanthin have the anti-osteoporosis activity and immunostimulation and fatty liver prevention activity. So the beta-glucoxanthin also suppress the blood sugar level. The nobiletin, a kind of polymetoxyflavonoids, nobiletin have the anti-allergy functions and anti-obesity functions. So the nobiletin also has the many functions. So all of them, the kind of coumarins, the immunostimulatory effect and the anti-inflammatory effect, and also osteoporosis improvement function have evaluated. So I'd like to introduce the, just wait. I'd like to introduce the evaluation of food functions. So at first, to evaluate the food functions, at first we using animal cell culture technique to evaluate the food functions. So we use many kind of animal cell lines to evaluate the functions. So after evaluation, by using animal cells, so the next step we will conduct the in vivo experiment using mice in living organisms. The experimental animals are used for evaluation of the effect in vivo, in body. Normally we use the mice. This is the mice. This is the very small animals. So the body weight is around 20 grams. So the oral administration of the food materials, and then evaluate the effect of the food intake. So after administration, we collect the tissue and then evaluate the cell activity in the tissue by cell culture technique. So this animal cell culture experiment to screen the function of the food extract. And next step is the animal experiment to evaluate the effect in the body. The final process is the human trial. So of course we are developing the functional food for human, not animals, not for humans. So finally we need to evaluate the food function in in our body. So this slide shows the in vitro assay by animal cell culture. So this is a culture media. We culture the animal cells. This cell is the kind of lymphocytes, immunological cell. In the liquid culture media, we add the food extracted in water or ethanol and other solvent. Then anyway, we put the sample solution, then culture the cells. And then after that, we correct the medium to evaluate the determination of some markers. And we also correct the cells to evaluate immunologic, enzymatic activity, enzymatic effect of food in cell. We use various animal cells. This is the immunological cells, human hybridoma. This is the kind of lymphocyte producing immunoglobulin. So this is the 33L1 cells. This is a pre-adipocyte. So this is the cell, and this droplet is the oil droplet produced in the cytosol. So we use this cell to prevent effect of on obesity. So we also use these two cancer cells to evaluate the anti-cancer activity, anti-tumor activity. So anyway, we are using many kinds of cells to evaluate the food functions. So we evaluate the anti-allergy effect, anti-inflammation, immunostimulation, anti-obesity, anti-NCD activity, so many kinds of functions we are evaluating at first using animal cells. So we move to the food function contained in the stratosphere. So at first, we'd like to introduce the immunostimulation effect of beta-cryptocyantin and the olaptin. This beta-cryptocyantin, beta-CRP are mainly contained in the stratosatsuma, and the olaptin is contained in Kawati Bankan, yellow-colored straws, right? We use these cells, we evaluate the effect of beta-cryptocyantin on IgM production by HB4C5 cells. As indicated in this slide, immunological cell, HB4C5 cell is a kind of lymphocytes, B lymphocytes. So these cells are producing IgM. So IgM is a major, very important antibody produced in our body. So produced by B lymphocytes. So the IgM production level of HB4C5 cells are dose dependently increased by the effect of beta-cryptocyantin. So this IgM production level can be activated by beta-cryptocyantin. So we evaluate how the beta-cryptocyantin affect on animal HB4C5 cells. So we correct the HB4C5 cells after stimulation by beta-cryptocyantin and correct RNAs, and then evaluate the quantitative analysis was conducted by using RT-PCR. So as a result, IgM gene expression levels can be activated by beta-cryptocyantin treatment. So beta-CRP stimulated IgM production by HB4C5 cells by stimulating gene expression. So this slide shows the effect of beta-cryptocyantin on Ig immunoglobulin production by splenocytes. In splenocytes, expresses the cell mixtures containing some lymphocytes. So we evaluate the effect of beta-glucoxanthin on Ig production by splenocytes. So IgA production, IgG productions are clearly stimulated as shown in this figure. So IgM also stimulated, but not so clearly compared with the effect on IgA and IgG. However, gradually increased. So this slide shows the effect of oraptin, another immunostimulatory substances in stress peer. So oraptin also stimulated IgM production by HbA4c5 cells, as shown in this slides, in this figure. So also evaluated the effect on gene expression level. So the oraptin clearly significantly stimulated the gene expression level. So oraptin also, as well as beta-glucoxanthin, oraptin also stimulated IgM production by HbA4c5 cells by activating gene expression level in HbA4c5 cells. So we also evaluate the effect of oraptin on Ig production by splenocytes. IgA as well as beta-glucoxanthin, IgA production and IgG production are dose dependently stimulated by oraptin. However, not effect on IgM production, no stimulative activity on IgM production by splenocytes. Only IgA and IgG production was stimulated by oraptin. So this slide showed the effect of oraptin on mesenteric lymph node. This is the intestinal immune responses. Participate in the intestinal immunological responses. So MLL lymphocytes were collected from mice and then evaluate the effect of oraptin on MLN lymphocytes. So IgA and IgM production was clearly stimulated. However, no effect on IgG production. Anyway, oraptin can stimulate lymphocytes to activate the immunological activity. So next, we evaluate the effect of oraptin in vivo in mice. Oraptin was orally administered to mice for 2 weeks. And then after 2 weeks, we collect the serum and the spleen. This is the immunological organ. So we retrieve the lymphocytes from spleen. We collect the splenocytes from spleen to evaluate effect of oraptin in vivo, shown in this figure. So the oral administration of oraptin significantly activated IgA level, as shown in this figure, as shown in this slides. So, however, IgG serum level and IgM serum level was not so clearly activated. Only IgA level can be activated by oraptin intake. This is the effect of oraptin on Ig production activity of splenocytes about the ex vivo. So the IgA, IgG, and IgM production activity of splenocytes from all of them administered mice very significantly activated, as shown these figures. So this means the intake of all of them can activate the immunological cells in mice. So it have the immunostimulatory activity. So this also the other immunological proteins, interferon gamma, interleukin-4, and TNF-alpha production was evaluated. So interferon gamma, interleukin-4, TNF-alpha production by splenocytes significantly activated, as well as antibodies. So this is a summary of the immunostimulation effect of oraptan and beta-glucoxanthin. Oraptan and beta-glucoxanthin stimulated Ig production by splenocytes and MLR lymphocytes in vitro. Then in vivo experiment, intake of oraptan can activate the serum IgA level and Ig and immunological protein production level by lymphocytes from in spleen and in mRNA. This immunological organ can be activated by intake of oraptan. So this data clearly show the beta-glucoxanthin and oraptan have the immunostimulatory activity. So immunostimulation is very important under this pandemic situation. We need to activate immunological cells to prevent from infectious diseases. So so eating stress is very important to activate the immunological cell. However, we need to eat the pear, because the oraptan and the beta-glucoxanthin are mainly contained in pear, stress pear. So we need to eat the pear. So this topic is the anti-allergy effect. This is the major topic of today's seminar. So the anti-allergy effect of stress component. This is the nobility, polymethoxyflavonoid. There are 6 methoxy groups and flavonoid backbone. Nobility is the flavonoid isolated from citrus pear. It is an O-methylated flavone that has the activity to rescue bulbar-induced memory impairment. So, and the nobility was found to have anti-inflammatory and anti-tumor effects in vitro and in vivo. So, nobility also was also found to potentially inhibit cartilage degradation. However, we are focusing on anti-allergy effect of nobility. So this slide summarizes the type 1 allergy. Pollinosis is a kind of type 1 allergy, but the pollinosis is the major problem for Japanese people. 1/3 of Japanese people suffer from pollinosis. So the pollinosis is serious, very serious problem in spring season. So the stress crisis of type 1 allergy. So these 5 processes, mast cells and basophils participate in the type 1 allergy. There are IgE receptor. There are Ig receptors on cell surface of these 5 cells, mast cells and the basophils. So the anti-pollen, pollen IgE are binding to the basophils or mast cells via IgE receptors. And then pollen are embedded in our body as antigen. So the pollen bind to the IgE on cell surface. So binding of pollen stimulate the activity of degranulation. So in granule, the granule containing histamine and rogatorium, these two chemical mediators stimulate the epithelial cells to induce the symptoms. So, but the histamine and rogatorium are contained in the granules inside of the mast cells. However, allergen stimulation induced a degranulation to release the histamine and rogatorium to stimulate the epithelial cells. So this is the mechanism of the pollinosis symptoms. So don't forget the word degranulation. This is the very important word of my presentation. This is the large basophil cell line, RBA2H2 cells. We are using this cell to evaluate the anti-allergy effect, anti-degranulation effect. So nobiletin suppress the degranulation in a dose-dependent manner at the more than 30 micromolar. Nobiletin suppress the degranulation by RBA2H2 cells. So this slide suggests the nobiletin can suppress the type 1 allergy. So this is the cell signaling, intracellular signaling pathways downstream of the IgE receptor. Fc-R1 is the IgE receptor on mast cells and the basophils. So antigen stimulation via IgE receptor, Fc-R1, induce the two kinds of signal transduction in basophils and mast cells, lane-6 pathways and the PSC kinase pathways. So we evaluate the effect of the nobiletin on these degranulation signaling pathways activation. So as a result, nobiletin can suppress the PIC kinase activation. Phosphorylation, PIC kinase can be activated by phosphorylation. However, nobiletin suppress the phosphorylation level in basophils after antigen stimulation, clearly decreased, as well as wortmannin. This wortmannin is a drug medicine to prevent the degranulation. So nobiletin can suppress the degranulation like this. So the downstream of the PSC kinase, AKT and PLC gamma 1 and so can be down-regulated. So nobiletin can suppress the PSC kinase. Then the downstream factor such as the AKT and the PLC gamma 1 and the PLC gamma 2 activation can be suppressed. Then increasing calcium ion concentration was suppressed, and microtubule formation also suppressed by nobiletin treatment. Then finally, degranulation can be suppressed by nobiletin. This slide shows the type 1 allergy model mice. So nobiletin intake significantly suppress the degranulation in ear. So as well as compared with the wortmannin, as almost same activity. So nobiletin can very strongly suppress the degradation in ear. So the health function of such-peer components, synergistic effect of nobility and the beta-glucosantin, beta-lactoglobin, sorry, this is the beta-lactoglobin, is the milk protein. So the combination of nobility and beta-lactoglobin is very effective on anti-allergy effect, anti-degradation effect. So as I mentioned, stress peer is not good taste. So, but we need to eat stress peer to prevent the type 1 allergy because it contains the nobility. However, the taste is not good. So, however, even though the food have the very good function, but we do not want to eat the not good taste functional food, even though it has a very good functions. The taste is very important. So the stress period itself not good taste. So we need to evaluate the synergistic effect to reduce the amount of eating stress peer because of bad taste. So the beta-lactoglobin, it is a milk protein. The beta-lactoglobin, beta allergy is the major whey protein, milk protein, or in species, and also present in the milk of many other species. In a previous study, our previous study also revealed the beta allergy moderates immediate type allergy. This means the degeneration. So beta-lactoglobin can reduce the degeneration as almost same as nobility. So as shown in this figure, beta-lactoglobin treatment can reduce the degeneration by RBA2H2 cells, as shown in this figure. So we try to evaluate the synergistic effect between nobility and the beta-lactoglobin. The nobility itself and the beta-lactoglobin itself can reduce degeneration, as shown in yellow colored bar and the green colored bar. However, combination of nobility and beta-lactoglobin at this concentration can significantly suppress the degeneration compared with the nobility itself and the beta-lactoglobin itself. So this means that there is a synergistic effect between combination of the nobility and the beta-lactoglobin for anti-allergy activity. So this slide shows the poinosis model mice, effect on poinosis model mice. The yogurt containing the beta-lactoglobin, stress peer containing the nobility. So administration of the peer yogurt also can suppress the poinosis symptoms. However, combination of stress peer and yogurt significantly suppress the poinosis symptoms in mice. So the why synergistic effects can be observed by combination of the nobility and the beta-lactoglobin. We evaluate the mode of action. So PRC kinase can be decreased by nobility. On the other hand, beta-lactoglobin can suppress the Syk. So the downstream of the Syk, the PLC gamma 1, 2, calcium ion concentration increase can be decreased, can be inactivated by beta-lactoglobin. So because of the different part in the signaling pathways, nobility can suppress PRC kinase, beta-lactoglobin can suppress the Syk activation. So this, because these two factors can be suppress the different signaling molecules, so we can observe the synergistic effect. So next step, we tried human effect on human. So this is the poinosis patient. So this is the poinosis symptoms in eye. So the intake of the yogurt can suppress the allergy symptom, poinosis symptom in eyes. So we developed the N+2 yogurt. This yogurt plan to develop the combination of the citrus peel containing nobility and the yogurt. Yogurt made from the cow milk, so they also contain the beta-lactoglobin. So the adding citrus peel to the yogurt, this means the synergistic. This product can be have the synergistic effect of nobility and beta-lactoglobin. So to develop this products, we collaborate with the many students. These are students of Ehime University, and company person can collaborate with the development of the food, development of the citrus peel yogurt. That this package was designed by students. The naming also, N+ drink yogurt, the naming also developed by the students. So this is this also synergistic effect between the academia and the industries. So there are so many kinds of N+ drink, N+ products. This is a yogurt. The package was a little bit changed, but the content is also the same. This is the premixture of the whey protein and citrus peel. This is a jelly, and these are tablet, and these the sweets. This is the cake. This is the ice bar. So there are so many kinds of N+ products. So we are collaborating with many Indonesian universities. So there are these Indonesian specific local food products. We are evaluating the functions of these products by university collaboration between Japan, Ehime University, and many universities in Indonesia, UGM, University Papua, University Jember, ICR, ITERA in Sumatra, UPM, and we would like to. I'd like to collaborate with the University Terbuka in future to evaluate the functions. Okay, thank you for your kind attention. I finished my presentation. Thank you very much.
Okay, Professor Sugahara, thank you for the presentation. We also would love to work together with University of Ehime in the future. So before we move on to the Q&A session, let me summarize the presentation itself. So we can conclude that Ehime is one of the top prefectures in Japan to produce citrus. It has 42 different varieties in Ehime. So in citrus, we have functional substances such as vitamins, but most importantly, the ones that are more unique in citrus are beta-cryptosantine, nobiletin, and auraptin. So we can see from the presentation how beta-cryptosantine and auraptin has an effect on immunostimulation, mostly auraptin, and how it affects the antibodies production. And then we also have the explanation about nobiletin, which also contains the effects of anti-allergy, especially when combined with beta-lactoglobin globulin from milk. So that's why Ehime University has been with the cooperation of universities and industry and students, the products of yogurt N+ and other N+ products are also made. Thank you, Professor Sugahara. Now we are going to move to the Q&A session. This Q&A session. Yes, of course.
Thank you so much.
The Q&A session will be for 35 minutes. To all the participants, we invite you to ask questions regarding today's presentation. You may ask verbally using the raise hand feature or through the chat column using the English and Indonesian, and we will try our best to translate the Indonesian questions. If anyone would like to ask now, we have the first question from Dr. Nadia of Universitas Terbuka. She said, as I know, Japan food scientists like to research some food sources from farm to table. In your research on citrus, what kind of citrus that is best for making fresh juices, and which one of the citrus that can be a kind of product have more time storage before it consumed? While that benefit of the citrus still we can get.
Yeah. As I mentioned, so each citrus contains each specific health functional substances. Citrus satsuma containing beta-glucosanthine, kawachi pangan citrus containing the olaptin. So we need to drink each citruses to have the such kind of functional substances. So we need to the best way to mix with the many citruses. However, not fruits, but we need to eat pear. So if you squeeze the citrus, you need to not only fruit, but also the pear components should be contained in the juice. So this is a very important point. Not only fruit, but also the pear can be taken. So when you made the juice, you need to squeeze the pear. Okay. So the active substances in citrus, such as the beta-glucosanthine and olaptin, these components are very stable. So maybe the storage feature is very good. So you can take such kind of active substances for a long time when you have the citrus juice containing the pear components. Yeah, thank you.
Okay, thank you, Professor. So that's the explanation from the professor that we need to eat not only the meat of the fruit, but also the peels of the citrus itself to get the most out of it. Now, the second question would be from Mrs. Endang Indrawati of UT. Professor Sugahara, you mentioned that in citrus peels, although it's not good to eat and have a bad taste, but very useful since citrus have an anti-allergy effects. Yeah. How to reduce the bad taste of the citrus peels to enhance many kinds of food products?
Yeah, it's a very difficult matter because the mainly nobility also the functional substances, the taste of the functional substance, not good taste.
Yeah.
So we need to eat. You need to take the citrus peel even though you feel the bad taste. So because the bad taste, the active substances is the taste of active substances but normally bad taste. Yeah. So this is the reason why you need to mixed with the other food stuff to reduce the bitter taste. Like milk also. Milk also can be reduce the bitter taste because of the lipid component. So it's the best way to reduce the taste by mixing combined with the other food stuff. Yeah.
Okay. Is it also possible to separate the taste of the citrus and the active substances? Like isolating the bitter taste in itself? Is it possible to do that? Or
So sometimes it's good.
Okay. The next question is from Adeline of Universitas Terbuka. She wants to ask, in citrus, the highest nutrition is which substance has the highest nutrition? If we see the technology in Japan, how do we keep the nutrition in it? As we all know, citrus has a lot of vitamin C, and vitamin C is very sensitive to light and will be degraded if there are any heating and any production, any process happening to.
Thank you. So antioxidant activity is very important. So the citrus also containing much vitamin C. So it have the antioxidant activity. So the citrus juice and citrus peel are containing the vitamin C. So it can be reduce the oxidation. So this is along the activity of the active substance in stress. So this is very important point. Yeah.
Okay. Great. Thank you. So we need to reduce the stress of the
that's right.
For the fruit itself.
Yeah.
Okay. The next question would be from Mr. David Priyandana of Universitas Terbuka. Can orange peels be made into snacks other than yogurt production?
Yeah, of course. It depends on the taste. It's a good point. The snack, we can eat the snack very easily. So so easy intake very important to prevent allergy. So for the functional food. So the snack also very good point to develop the functional food using citrus peel. Yeah, thank you.
Okay. Professor, thank you for your answer. I want to ask something about because you said that this product is the functional components of the citruses is very stable, such as the modulating. So I would assume that it's very easy to be processed into using heating and such. Is it as sensitive as vitamin C? Because, for example, if you want to make snacks, you need to have some kind of heating on it. Is that possible? Like to make chips using the peels?
Very heat stable. Nobility and beta lactoglobin is a protein, milk protein, also very heat stable. So the heating is normally normally proteins can be destroyed by the heating treatment, but beta lactoglobin is very heat stable. It can be active after boiling for 1 hour. So very heat stable. Nobility also very heat stable. So we can use the citrus peel and nobility and beta lactoglobin for the snack and the other food. It need to be heating. It need to be heated. Yeah.
Yeah.
No problem.
Okay.
No problem.
Thank you.
Yeah. Thank you.
Okay. Maybe I would like to make some for myself.
Yeah. So develop some functional food in Indonesia.
Yeah. Okay. We have another question from Aisyah Ramadini. How many doses of citrus pills to any kind of food so the food won't be taste bad? So, and is it just specific kinds of citrus pills that has anti-allergy effects, or all kinds of citrus pills has this anti-allergy effect? So you mentioned there are 42 varieties of citruses in Ehime. Do they all have the anti-allergic effect? Do they all have nobiletin or?
Yeah. In our study, nobiletin is the key substances for anti-allergy. So the citrus pill which containing the nobiletin can have the anti-allergy effect. However, some kind of citrus does not contain the nobiletin, so it's not good for anti-allergy. So because you need to choose the nobiletin containing stresses. So the taste of nobiletin is not so good. So you need to reduce the nobiletin intake. So in the yogurt, nobiletin is contained at 0.5 milligrams. The yogurt, one bottle of yogurt containing the almost 0.5 gram of peel powders. So it containing the 0.5 milligrams of nobiletin. So the important point is you need to combine with the beta-lactoglobulin to effectively reduce of degradation. So the beta-lactoglobulin, it needs 150 milligrams of beta-lactoglobulin is needed to combine 0.5 milligram of nobiletin. So the 0.5 milligram of nobiletin and 150 milligram of beta-lactoglobulin. This combination is very good for the anti-allergy. So at this point, the taste of yogurt is not so bad. A little bit, maybe you feel it's just yogurt, but you feel a little bit citrus flavor, just citrus flavor, not so bitter. Yeah, it's very good taste. Yeah. So to reduce the if you use the only nobiletin, you need to eat more. You need to eat more citrus pill. However, if you combine with the yogurt, you can reduce the citrus pill amount. Then, however, you can feel the anti-allergy effect by eating citrus pill yogurt because you can reduce the amount of citrus pill in the products. So the taste is maybe the taste is good. Just you feel the citrus flavors. Yeah, thank you.
Okay. So we have another question from Adeline of Universitas Terbuka. We know that modern technology in Japan is very advanced. If the citrus fruit food is processed using modern irradiation technology, is that possible? And what are the effects?
Modern irradiation technology. Yeah. May it be possible. Yeah.
We have to.
I don't know the effect. We need to evaluate the effect after irradiation.
Okay.
I don't know what kind of change will be induced after irradiation. I don't know.
We need to do more research on that.
Maybe that's right. Yeah.
Okay. Next question would be, oh wow, It's in Japan.
in Japanese. Yeah.
He said, "Konnichiwa, Takuya-san.
Yeah.
Today."
You can read Japanese.
Yeah, a bit. There's Hajime. She said her name is Jessica and from University of Terbuka. How is Japan able to produce quality food with limited land and limited number of people?
Yeah. It's just a effort of the farmers. Just a effort of the farmers. The farmers watching the stress tree and watching the stress fruit, and then they very high. They have the very high skill to produce the high quality fruits. So it's just a effort of the farmers. Yeah, just effort. Thank you.
Yeah. Okay. Any more questions? Not yet. Okay. Well, maybe I will ask one more question. So you mentioned that the nobilatin works on type 1 allergy, but it also works on type 2 and a more hypersensitive type of allergies.
Yeah.
Will that work also? The nobilatin.
Yeah.
It will work on type 2 allergies and stuff.
Not type, just on for the type 1 allergy.
Okay.
Yeah.
Okay.
Acute phase allergy. Yeah.
Okay. Lanjut nih. Okay. I think that's about every question that we had for today. That would mean that will be the end of the Q&A session. Thank you, Professor, for answering all the questions. I hope it enlightened us more about the effects of functional foods such as citruses can have on our health. So next, we would like to thank Professor Sugahara for his time and for sharing his knowledge for today's lecture. We have learned a lot about how citrus functional foods are made and how they are developed in Japan. And next, I would like also to thank all the participants for your participation till the very end of this lecture. I would like to apologize for any mistakes or unintended words that I used during my time as the moderator for today. To Mrs. Hakiki, I will give you the time back to you. Wassalamualaikum warahmatullahi wabarakatuh. Thank you, Professor Sugahara.
Thank you very much. Thank you.
Thank you, Mr. Rajih. Now I would like to ask Dr. Radiansyah, University M.Sc, as the head of Technology Study Program, to give a certificate as a token appreciation to our speaker, Professor Dr. Takuya Sugahara, Ph.D. Please, Dr. Radiansyah, if you may.
Hakiki, to Professor Sugahara, we would like to thank you for your time and for sharing your knowledge today. As a token of our appreciation, Food Technology Program would like to award you with this certificate of appreciation. Thank you, Professor Sugahara, and arigatou gozaimasu.
Arigatou gozaimasu. Thank you. Thank you so much. Thank you for the satisfaction. Thank you. Thank you so much.
Yeah, thank you very much.
And then, before we close the guest lecture, I would like to invite all participants to take picture together. So please activate your video. And I would like to ask ICT to help us take the picture. Mr. Mahdi and Mr. Devin, if you may.
Okay, get ready. 3, 2, 1. Again. 3, 2, 1. Last. 3, 2, 1. Okay.
Okay.
Thank you so much.
Yes. Thank you so much, Sensei. Ladies and gentlemen, we have finally arrived at the last agenda of this lecture. Before we end this event, I will give some announcement. Don't forget to fill the attendance and feedback form in chat box. Certificate for participant will be delivered within 2 weeks in this lecture. And on behalf of the Fakultas Study Program Team and Faculty of Science and Technology Universitas Terbuka, we would like to thank our speaker, Professor Takuya Sugahara, Ph.D. Thank you, Sensei. Hontou ni arigatou gozaimashita.
Thank you so much. Thank you. Arigatou gozaimashita. Thank you.
And also for our participants, thank you, and we apologize for any unintentional mistake. Ladies and gentlemen, we hope you enjoyed the knowledge sharing session, and we could hope to see you again in the next guest lecture. Wassalamualaikum warahmatullahi wabarakatuh.
Warahmatullahi wabarakatuh.
Sensei.
Thank you.
Thank you. Thank you so much. Thank you. Thank you so much.
Committee.
Yeah. Collaborate in future.
Yes, we can collaborate in the future.
Yeah. In the future. Maybe I will come
go to our
Indonesia in
university,
future.
Sensei.
Yeah.
That would be great. You should visit us in Universitas Terbuka.
Maybe next year I can come to Indonesia. Maybe.
Yes.
After pandemic. Yeah.
Yeah, looking forward to that.
We would wait for your attendance.
Thank you. Thank you so much.
Mungkin Bu Nurma ada pesan untuk
Thanks for all, Professor Takuya Sugahara, for
Yeah, thank you.
and for your sharing. Okay. Thank you. Goodbye.
Yeah. Bye. Thank you so much.
Thank
Bye.
Bye.
Thank you.
Thanks for all.
Professor.
Thank you. See you.
See you.